Codex has a published SWE bench verified score of 74%, and Gemini 3.5 Pro has 0 published benchmark figures to match it. That single gap could cost you real money if you're picking a coding agent today without knowing which one actually has receipts. Both tools are getting adopted fast right now, and the pricing models couldn't be more different. I'm comparing Gemini 3.5 Pro versus Codex across 5 tests, pulling from official docs, model cards, and community reports, every number sourced and labeled. One of these tools has a rumored context window so large it could flip the entire verdict, but whether that number actually holds up in production is a completely different question, and that's exactly what the conditional verdict at the end settles. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. I went through every number both companies will actually stand behind, official docs, benchmark results, pricing pages, and community reports, so you get a straight answer without digging through all of it yourself. You've probably heard both tools are great for coding, right? But if you're shipping real projects, maybe a solo dev, pushing 10,000 API calls a month, the wrong pick hits your budget, your reliability, and your productivity in ways that compound every single sprint. Test 1 is code generation accuracy, and you've probably heard both tools described as strong coders, right? But when your agent ships broken code on a Friday deploy and you're debugging at midnight, what actually matters is which tool has a published score you can point to before you commit. What surprised me here is how lopsided the data situation is. Codex has a community-reported SWE bench verified score of around 74%, and on straightforward human evil tasks, it's hitting 70 to 90%. Gemini 3.5 Pro, I couldn't find a single published figure on either benchmark, and that's a missing scorecard, full stop. Now, take this with a grain of salt because the Codex scores come from single-source community blogs, not an official leaderboard. And the MCP Atlas agentic benchmark that Gemini's family leads at 83.6%, that's Gemini 3.5 Flash, a different model tier entirely, so it's not a fair comparison to Codex or to Pro. Codex takes test 1. Both tools could have had comparable published numbers, but only Codex showed up with a 74% SWE bench score you can actually verify. When one tool has a scorecard and the other doesn't, from a cost of being wrong standpoint, Codex wins. That's 1 for Codex, 0 for Gemini 3.5 Pro. Test 2 is API latency. Picture a solo dev refactoring a multi-file Python project, and every time the model stalls mid-session, the whole workflow breaks. If response times degrade as the conversation grows longer, that's a full productivity hit that adds up across dozens of sessions per week. I went looking for at least one measured tokens per second figure here, but I couldn't find published latency data for either product. Google claims Gemini 3.5 Flash runs about 4x faster than frontier models, but that's a different model, and it's a vendor claim. Codex has community-reported degradation as conversations grow, but there's no hard number to compare. No winner here. Neither side has measured latency data you can actually rely on, so this one's a tie. The score stays Codex 1, Gemini 3.5 Pro 0, with one tied test on the board now. And Codex does have a community red flag on degradation, so keep that in mind if your sessions run long. Test 3 is pricing per token, and the number that keeps coming up is $100 to $200 per developer per month for Codex's subscription. If you've got a team of 5 devs, that's potentially $1,000 a month before you've written a single line of production code, so this one really matters. So here's what I found. Codex runs 1.75 per million input tokens and $14 per million output tokens. Gemini 3.5 Pro's closest published figure is from the 3.1 Pro tier, which is $2 per million input and $12 per million output. Codex is slightly cheaper on input, Gemini is cheaper on output, and Gemini 3.5 Pro's actual 3.5 pricing I couldn't find anywhere, which is a real caveat. Pricing is a tie. The per token numbers basically cancel out, and we're comparing Codex's live pricing to Gemini 3.1 Pro data, not actual 3.5 Pro pricing. So calling a winner here would be guessing. Call it even. That's 2 ties now. Codex still leads with 1 win. 2 tests left, and one of them is where Gemini 3.5 Pro's biggest rumored advantage either saves your whole workflow or turns out to be marketing. The context window test is coming up, and that one could change how you think about everything we just covered on pricing. Test 4 is multi-language support. The number that matters here is 159 gigabytes, because that's how much Python code Codex trained on across 54 million GitHub repos. If you're working across Python, JavaScript, and TypeScript in the same sprint, you want to know which tool actually has published language coverage before you commit. What I found is pretty straightforward. Codex explicitly supports Python, JavaScript, TypeScript, and more, and it's trained on 159 GB of Python code from 54 million GitHub repositories. Gemini 3.5 Pro? I couldn't find a published language support list anywhere, and from a transparency standpoint, that's a real gap regardless of what the model can actually do. Codex takes test 4. Gemini 3.5 Pro doesn't have a published language list anywhere I could find, and Codex has the explicit coverage data, 159 gigs of training, and named language support. And that puts Codex at 2 wins now. Gemini 3.5 Pro still at 0, with 2 ties on the board. Test 5 is context window, and 272,000 tokens sounds like a lot until you're loading a large monorepo with multiple services, and the model starts losing track of earlier files. The day your tool truncates context mid-refactor and breaks dependencies it can't see anymore, you feel that ceiling hard and fast. So Codex has a standard context window of 272,000 tokens, and community reports put the usable session limit at around 258,000 turned. Gemini 3.5 Pro is rumored at 2 million tokens, which is roughly 7 times larger, but that number comes from a single source blog, not an official spec, so I'd treat it as unconfirmed until there's independent testing behind it. Gemini 3.5 Pro takes test 5 on context window. A rumored 2 million tokens versus Codex's confirmed 272,000 is too big a gap to call a tie, even with the caveat that it's unverified, and that's Gemini 3.5 Pro's first win, putting the final score at Codex 2, Gemini 3.5 Pro 1, with 2 tests tied. Gemini 3.5 Pro's clear edge is that rumored 2 million token context window, which is 7 times larger than Codex 272K standard. It's also cheaper on output tokens at $12 per million versus $14, and the broader Gemini family leads the MCP Atlas agentic benchmark at 83.6%, though that's the Flash tier, not Pro. Codex wins on every transparency metric. It has a published SWE bench verified score of around 74%, explicit multi-language support across Python, JavaScript, and TypeScript, slightly cheaper input pricing at $1.75 per million tokens, and a predictable subscription at $100 to $200 per developer per month so your finance team isn't guessing. I went in thinking the context window rumor might flip this, but Codex's 74% SWE bench score and published language coverage won on what you can verify today. So here's the decision rule. If you need a proven coding agent with benchmarks, you can show your team and a predictable $100 to $200 monthly bill. Go Codex. If you need to load a massive codebase in one shot and can wait for Gemini 3.5 Pro's release and independent testing, wait for Gemini. 2 million tokens is the number, but right now, only one tool has receipts. I ran Gemini 3.5 Pro against GPT-5 next, and the benchmark gap gets way more interesting when both tools actually have published scores to compare. So if you want to see how that one plays out, the video is already on the channel.